years now, and I'm in the advanced engineering team in the research department, let's say. So it's more likely to scale up, but also some research questions are addressed there. In Radevormwald, my personal I live in Bonn and I have to go there frequently, but the research department is in Radevormwald, and our production is in North Italy, in Únete. I want to tell you about the industrial applications of Metal-Hydrides. We have seen some academical research on Metal-Hydrides, especially on those with a higher specific energy. We are working for now with ferrotitanium because the high temperatures of these reactive compounds and also the academic nature that they are still in is hindering to become into the industrial area. Even with the ferrotitanium, we have in the scale-up process some challenges that we had to overcome. Most likely, some are still there. We are beginning to sell systems now, to build systems really in a large scale in an automatized way. So our background, maybe first to understand where GKN comes from, the name GKN, but also our mindset, or a huge portion of our mindset is from a huge global company. GKN Powder Metallurgy is the #1 global share of sintered metals compounds, especially for cars, for automotive. So steering compounds, things that have to be extremely safe and extremely precise. They are made by sintered, by sintering process. So that means we need a powder. We press that to a greening, and then they are heated until it's like baking a sandform, so to say, with a binder, in order to make the piece, the part in a very, to give it the shape we want to. The process needs metal powder, and inside of the company they bought GKN Höganäs, which is the world #2 for metal powder delivery. So GKN could provide the whole process between the powder until the ready part for the automotive industry. And 2014 or 13, Smart Group was considering the automotive industry to be a dead end, or at least a declining end, and therefore was developing two different market approaches. The first one was GKN additive, like 3D printing of metals, which is still inside of GKN Powder Metallurgy, and the second one was GKN hydrogen. Not listed here is the magnetic part for electric motors, which is now advancing, or let's say commencing. We had our market launch for our Metal-Hydride storage systems in May 2021, and are now split from GKN PM. So we are a standalone company now, which poses a lot of challenges with all the HR and all the legal stuff and stuff. We had a huge system, a global system. We have had people at 4 sites, Bonn, Únete, Radevormwald, and in the US. So now we have 80 people around the world, and we have to somehow coordinate that. I guess I don't have to show you this. We have to meet very ambitious CO2 emission savings if we want to keep to the 1.5 degrees Celsius scenario of the Climate Committee in Paris, which we all agreed on. And yeah, what we can see on the right side is the approach is how to get there to this industry savings. We will have to have chemical compounds. We have to have renewable energies for electrical in almost all sectors, we have to, let's say we have to convert many systems to a different system at the same time. And hydrogen is always one player in this field. So it's coming up in the mid-sized future, let's say, later. Also, what we see is that our electrical energy grid is transforming from rotational-based power plants towards wind and solar energy, which is challenging because the wind is blowing whenever it is blowing, and it's not blowing whenever it's not blowing. So we need a solution for that. And the more of the percentage of the renewable energy is, we are now somewhere here, the larger and the more seasonal the storage has to be. So you can imagine that if you have 2 solar cells, this is like neglectable compared to all the coal power plants. But if you have like a huge percentage of solar energy, you will have to store at least day to night, which is an hourly or intraday basis. But later, if it has a rainy week in some regions, you will have to store that as well, and then we are in the weekly season. So to say, we are going into the direction of larger storages that can provide energy for seasonal storage for winter, summer cycle or something like that. And this sounds easy, but the one major challenge is the digitalization of the thing. So you have, at first, you have batteries, and you have maybe in the near future also but maybe other hydrogen storage devices. And now you have to control which electricity flows where. So we come from the renewable energies whenever they are there, and we have to store it in some system. So we have to route the electrical current to the most efficient way. This means like the efficiency of batteries is probably higher than any hydrogen system so far because of the electrolysis and the fuel cell. So we would want to have the battery full at first. At the same time, you would want to have the electrolysis running as long as possible, because then the efficiency and the purity of the hydrogen goes up. So there's many contradictory things that are running, and you have to manage all these systems together, which is a very high value addition in the future. So this is probably something where huge companies are making their money, or at least the small energy engineering companies will have a little money from it as well. And the next thing is nobody will buy a system that cannot cope with this problem. So you can have the most sophisticated metal hydride if you cannot manage the electricity. If you don't have a bad balancing of plants, nobody will buy it, or the customer will be unsatisfied. So what is our approach? We use ferrotitanium, I said that already. That doesn't mean we rule out the others, but this is just the most mature one, which we can use the most easily for a scale-up into an industrial sector. I think we have seen some others before, so I will skip this. Of course, in principle, like this is a modified Ragone plot for hydrogen, and of course we want to go into this direction. And here we are already fine. The volume is usually not our problem, but we are very heavy. We want to get lighter or store more hydrogen. So what we do is we store hydrogen in a metal hydride in a compressed sample. So you can see these discs here. These are compressed because of our background from GK and powder metallurgy. So we have our own powder, and we have our own process, our own presses, and we design all that with the background of the powder metallurgy in our engineering head. Of course, you would need the metal hydride to be thermally controlled. That's why here is a tube-in-tube solution. We have a flow of a thermal fluid in the outside tube, which of course may never touch the metal, because this will oxidize them. Yeah, this is like some things that our advertisement department designed. So this is just to show you again that metal hydride is a really dense and secure way of storing hydrogen, which probably you all know, hopefully. We have heard it in my previous speaker. So the GKN history is like we started 2013. I already said that. We had 2019. We had an interesting installation, the first demonstrator in the Alps. There is a mountain hut that has all its power from water flow generator, water turbine. And this water turbine doesn't provide any electrical current in the winter because the small river is freezing, and therefore we installed a system which can convert all during the summer electricity into hydrogen and puts it into the metal hydride tanks, and can use it in the winter time. So everyone talks about seasonal storages as something that comes up in the future. In special applications, it's already there. You can already buy it. You just have to take the extra money into your hands to buy it. Then 2020, there was a lot of demonstrators installed. There were 2 in Bruneck and 1 in Bonn. One very large one and 2 small ones. And yeah, 2021, we had our announcement that we will sell the system now, went into the market, and 2022, we have, I told you about the value addition by a good balance of plants. We have